Yep. Sounds like it was good.
Yep, that sounds good.
Okay,
Okay,
all set.
so
Okay, so I should
John
start.
Morowitz, do you want me to introduce you? or-
Up to you. I think you sort of did. Up to you.
Okay. All right, okay. John Morowitz is an avid hiker, camper, and amateur photographer with a conscious addiction to Mount St. Helens and the Grand Canyon. Rather than viewing these locations as places he's already seen, he looks forward to seeing them again on different trails, in different seasons, and with different groups of friends or alone. So take it away, John.
Okay, fair enough. So if you see my screen, the picture behind me is Spirit Lake, very calm at the time, and Mount St. Helens behind me. So with that, I will just go forward. This is what the volcano looked like before 1980. It was called the Fuji of the Northwest. It was very cylindrical cone, beautiful snow-capped glaciers, etc., and Spirit Lake in the foreground. But it was very active. And any geologist knew it. If you look at the fourth mountain down there in the Cascades, Mount St. Helens erupt numerous times. And they knew sooner or later what happened, and papers have been published that it will happen. And sure enough, 8:32 a.m., 1980, it erupted. And this is the picture most people see of it. And what often happens to volcanoes, but it's only one of four major geological forces that happened in that eruption, which, by the way, I should say, I'm not a geologist, very amateur, yes, addicted to the place, and I read up on it a lot. So the general location, there's a view sort of like more to the northeast. You sort of have a triangle of Mount Rainier, Mount St. Helens, and Mount Adams, north of the Columbia River in southern the state of Washington. This is more a map of what it looks like. There are three main ways, and we're going to go through these locations as to how to get to see the volcano from different points of view. The red arrow, you drive in on that road on the left, and you get to what's called Johnson Ridge, and you can look across the blast zone into the crater. The green arrow is a highway, twisty Highway 99, which goes basically through the forest, rises up, then it goes into the blast zone, and it ends at Spirit Lake right above it. The blue arrow is from the south, and these are the three main ways to get there. And that's where you go when you want to climb the mountain. You take that road, a paved road, maybe paved all the way now. You camp out, climbers bivouac, no water, but you camp out there, and then you climb the volcano from that point of view. So let's start with
There's an area in the Mississippi Delta that Black people have been farming for generations. The others are importing.
Can somebody mute?
Oh.
Okay, so 1994 was the first time I knew about the eruption 14 years earlier, but it was really courtesy of your tax money that we had a grant when I was working for the chemical workers, retired now, that took me to Hanford, Washington. I looked at the map, I saw that Mount St. Helens was a 3-hour drive, close to it, 3 to 4 hours. So I went. I knew enough to take snowshoes and didn't have a permit. You didn't need a permit that time of year, and climbed up on the snowshoes by myself until I felt it was sort of unsafe. And this is one of the pictures of that time. But I decided I had to come back. And I got really addicted to this place a lot because the first hike was really the best. So this is in 1996. I camped at Climbers Bivouac, woke up in the morning to hear campers laughing. I wondered what was up. I opened up the tent, and there was a cloud covered the mountain just about a timberline at 4,800 feet. So what choice do you have? You might as well climb the mountain, you're there. So what happened is you hike up, you hike through the fog, the cloud, and you come above the cloud. It's the most amazing view as you're climbing up. And you get to the top, that's the rim of the crater. And then 30 miles away to the east is Mount Adams. As I said, one of the three volcanoes form this triangle. What causes it? This is a technical picture that I shudder to put on. I know people here will start looking at this and want to know more, but basically there's a chamber of magma stylized in this picture underneath, miles underneath the volcano. There's a conduit, and scientists have studied all of this, and it rises to the top. They also know more recently that the same magnet chamber is connected to another area, Indian Heaven volcanic field, which is just to the east of Mount St. Helens. Now, did they know what was going on? Oh, they knew. So you can see here, you have this diagram, this graph of earthquakes that are 2, 4, 6, 8, and 12 kilometers underground. And in 1980, May 1980, there were a lot of earthquakes. And in fact, for 3 months before the eruption, there was activity at the cone and a crater was being formed and knew something was going to happen. And you can see the horizontal blue arrow to the right. Earthquakes continued, and we'll get to later, magma was extruded lava into the crater of Mount St. Helens. They also knew very vividly something was going to happen. This is the bulge in dotted lines, that basically the north side of the mountain was pushing out, up and out to the north. And this is fairly large. I'm not sure what the exact dimensions are, but it's more than a kilometer across. It also was rising up. When they first put some of the measurements with the laser lights that they were looking at spots on the bulge, they thought something was wrong because it was literally growing 5 feet a day. So clearly something was going to give. They just know when, where, and how much, and what it was going to be like. And they didn't expect the lateral flow explosion. There happened to be this guy, Gary Rosenquist, who was at a place called Bear Meadows, which is just about where the blast zone begins now. And these pictures are pretty graphic, just a couple of seconds apart, where the basically it was a huge landslide, the biggest recorded landslide in US history. And you can see in the right-hand picture that it's beginning to have a blast going upwards, but the clouds sort of lower down. It was a lateral blast also, and it exploded. What happened is the landslide went down first, but they've taken samples across the blast zone, and you can see they have areas where the dust from the pyroclastic, the gas dust explosion was on top of the landslide, and then the explosion happened faster, and it basically was below the landslide. The landslide covered it. This is more a stylized picture as to what happened. The landslide, horizontal blast, vertical blast. And this is your topographical map of what it looked like. It's on the left before 1980, a lot of glaciers at the top, and a lot of the glaciers got truncated. And I'll get to later, many of them turned into what's called mud flows or lahars, an Indonesian term for mud flows down the mountain. So your typical pyroclastic eruption that was to the top. This is what it looks like now, what it used to look like, chop the top off, as well as when you get to the rim, you're looking down 2,000 feet into the crater.
Can I ask 2 questions?
Sure.
First, that blast, there were 2 clouds. Does that mean there were 2 separate explosions on the mountain that created it? One horizontal, one vertical?
Yes.
All right. The second question is,
Wait, let me just add one other thing, Gary. The analogy you can look at is basically there's pressure of the lava, the water vapor underneath is superheated into steam. And basically when the landslide went down, it uncapped it. It's sort of like a can of soda. If you were to shake it up and pop it open, it'll just explode up. That landslide, as it went down, uncapped it. And it had 2 blasts, both vertical and horizontal.
Got it. Second question, that artificial picture you showed with the egg, and I take it they were caverns of lava. Is that correct?
I'm sorry, what's that again?
The artificial picture, I forget what you called it, but it was a diagram of what was underneath. It was in color, and there was an egg.
The first schematic you showed. but the oval magma chamber just
Yeah,
before
below that, yeah,
one.
that, okay. That inside is magma, right?
Yes.
How does the magma get in there?
It flow the bottom chamber recharge. Basically, obviously they can't study it, they can't go down, they can do various studies to look at it. But basically, I believe that what happens is that we're subducting part of the ocean floor is going under North America, or more accurately, North America is traveling to the west. And as it goes down, it carries seawater with it. The seawater lowers the melting temperature, and some of it turns to magma, and it rises up. Exactly more how that rises, the structure, I don't know.
I see. So it's not a channel, it's coming through the soil or the rock or something.
It's not
Okay.
soil, that's for sure.
All right, all right, all
Rock.
right. Thank you.
All right, so to give you some perspective, at the top right, you can see bare meadows, the edge of the blast zone. That's where those pictures were taken of the eruption itself. We'll show pictures in a minute of Norway Pass. You can hike to, which is above Spirit Lake, north end of Spirit Lake, and Johnson Ridge, where when you get to, you can look straight into the volcano as it erupted to the north, and you're looking due south. Other particular places where I'm going to go to, and I have to move this around, there is obviously the crater. There are hikes there. To the right, there's a place called Plains of Abraham, which is a very flat plain at the base of the mountain. Muddy Creek, which is where there's a larhar, and the summit climb, which is the down arrow for summit climb, is where you park the car and you climb up, and there's a trail and you go up to the rim. And the lower right is June Lake, where there was no eruption. The whole southern part of this is past what's called the eruption zone.
Can I ask you a quick question also?
Sure.
Just, I was just curious, the pictures that you showed earlier that were like a blast, was that like part of them studying the mountain, or was that just somebody who happened to be there that day with a camera?
Somebody who happened to be there with the camera and had it on the tripod. And there's a description if you Google his name, and he says he just didn't know what was happening. And something seemed to be shivering in the mountain. It was moving a little bit, and he immediately went to the camera, took pictures, took the last picture, and got out of there.
Wow.
So if you climb the mountain, it's very, you're in a forest for a while, then you're above timberline, it's very rocky, but there's a clear trail. And then it gets dust, sand, pumice, whatever you want to call it. It's the only analogy I can make is like you're hiking on a sand dune. And it's like every step you take up, 2 steps, you're sliding back down 1. The easiest way to do it is you do it in winter. It's pretty brutal, but it's frozen and you get crampons, you can go straight up it. It's very easy.
John, is there any hazard of an eruption happening while you're walking around up there?
No, but hold that thought. Hold it. So there you.
Wait, John, the guy who got out of there, if he stayed, would he have been hurt?
What?
The guy who escaped after the camera shot, would he have been hurt if he stayed?
Oh, yes. Oh, yes. Yeah, I mean, there were people who died who were past the eruption zone, that basically the pyroclastic flow is superheated gas with dust in it. It clogs people's lungs. And there were about 57 people who got killed, and many of them were outside the eruption zone.
Okay.
And can everybody please mute yourself if you're not speaking? Thank you.
So the picture on the right is the 3 people who I would hike up the mountain sometime in the, I think, early 2000s. And there we are, just sort of like where it's difficult going up, much easier going down. You're just slipping and sliding. The mountain itself, what you see, the edifice, is really very young, less than 3,000 years old. The base, there's a history of eruptions for a couple of tens of thousands of years. But you can see when you're on the rim, you can look and you can see the color changes where there were different layers. And I don't know which particular layer, what the time was for this one, but you easily see where there were different eruptions that built up the volcano. So now we're going to go more, I think, to Johnson Ridge and Spirit Lake. And this kept looking for the original in this one, very fuzzy picture. But this is overlooking Spirit Lake, literally from the parking lot at the end of Highway 99. Johnson Ridge is under the clouds and the shadow in the distance. There are trees, still logs, I should say, floating on the top of Spirit Lake. What happened is when the landslide hit Spirit Lake, it took all the water and it just pushed it up. In fact, at Norway Pass, it pushed it over Norway Pass, and you could see deposits of that on the other side. And then most of the water, though, washed back down with the logs on them, stripped soil away and the trees, but half of the trees, they estimate by now, have sunk at the bottom of a new Spirit Lake. Half of them is still floating around. And as the wind shifts, the logs move around. This is what it looks like at the shore. And this is what it looks like at Norway Pass, looking south across Spirit Lake into the volcano. And the white in the middle of the volcano, I believe, we'll get to that, is I believe the snowfield or glaciers that's inside the crater.
Hey, John.
Yeah.
Is this area considered a part of a national park, or what's the property?
I believe it's a national
situation?
monument, and there was a big argument at the time as to what to make it and how to restrict the logging. Weyerhaeuser owned a lot of the property. There was a trade-off as making the national monument, and they did take a lot of the logs out in the blast zone, which is too bad, because in some areas you look at it and you say, okay, the trees are destroyed. Well, maybe they were logged, they weren't destroyed.
Just
But you
thinking
see the
all that floating wood looks like nice driftwood at this point, which would also be, someone would also want to take out and use. But go on.
Yeah,
Okay.
40 years later, it may not be salvageable as wood, but who knows? I don't know. Waterlogged for 40 years.
That picture you had just before from the pass. Yeah. And that's the same pass you said that it sloshed over. That looks like it's pretty far down there now. So that was a lot of slosh. Is that, am I understanding that's the pass that it actually came up and over where you're standing?
Yes.
Wow.
Yeah. And actually in wintertime, fall, when you get these beautiful foliage, it's also the elk are rutting, and you can hear them and see them in some places.
Has
So-
Mount St. Helen always been a park, or did it become a park after the?
It became a
volcano?
park afterwards. It was not a park beforehand. Weyerhaeuser owned a lot of it, and some of the people who died were loggers. And there would have been more people killed logging if it had happened Monday morning. It ended up happening on Sunday morning. People were waiting to come in. There was a big tension. Can I get into my cabin on Spirit Lake? Can I get my stuff? They were waiting at the gate down the river out of harm's way. If gate had opened, the eruption had been 2 hours later, there would have been, I don't know how many more people killed. So this is facing north. This is in 1996, what it looked like, this lava dome that had grown, and snowfield, we'll get to that, more like a glacier around the lava dome in the crater. And that original lava dome was built between 1980 and 86. In 1980, it was fairly flat at the bottom of the crater. But there began soon thereafter to be extruded out of the chamber underneath some lava, and began extruding more. And it was, I forget the term for it, but basically it wasn't on the surface. It would be more of a pushing up underneath, and the top rock would just be pushed up. And it grew and it steamed, and there'd be some ash explosions, some minor explosions, and in winter it would be pretty clear where it had flowed. And it was pretty substantial in height. I don't have the exact dimensions. They come later. It's probably, I think, about 1,000 feet high. The other thing you got to say is anytime you're on the crater, there are landslides. It's very obviously unstable where it erupted. Even from the distance, you can see clouds rising with binoculars. And they all went down, and it came to rest at the bottom where there was snow there also. And there was a lot of snow at the bottom, more than usual, because the crater exploded, the volcano exploded to the north. Therefore, this picture is taken looking south, and you can see it's earlier or in the morning, because the crater rim on the east side is makes it casting a shadow over a lot of the snow at the bottom of the crater. And then the same thing would happen when it was to the south, and when it was in the afternoon, it would be the crater, the wall on the west would cast a shadow coming to the left. That all resulted in basically a glacier being formed around a semicircle, not at the front, but a semicircle between the wall of the crater and the lava dome. And it also had a large, much more than most glaciers, had I think 30% of it was rock and boulder and debris. Scientists studied it. So there are some peer review articles where they had looked into the caves. Very obviously, public couldn't do this, but they did go in, and there would be hot gases coming out, and they would explore the caves. Now, why isn't it advancing? There we go. So then there's Johnson Ridge, some pictures from Johnson Ridge, which is named after Dave Johnson, who was a geologist on the mountain close to where the observatory is now. And he basically that morning radioed Vancouver, Washington, where USGS has its headquarters, and said, Vancouver, Vancouver, this is it. That was it. Didn't hear anything more from him, and they never found his body. But this is the view from the observatory, which is the easiest place to get to. You can drive right to it. And from I-5, you take an hour going up and down the ridge line, and you look across the blast zone right into the crater, the mouth of the crater. And these hummocks are things that these little hills are part of the landslides, and they actually have mapped where they think this came from on the volcano. And it also helped them understand other volcanoes in the Cascades and around the world. I think Mount Lassen or some other volcanoes in the Cascades where they have the same kind of feature of these hummocks. Weather doesn't always cooperate completely, but sometimes it does. And it's quite a
What is a hummock and what can you learn from it?
A hummock is a hill. It's what it's
And
just
what-
a hill. And
what can you learn from it?
From looking at, I believe from studying the rock the hummock is made out of, and comparing it to the rocks that were part of the mountain before it erupted, they know where it came from. And Gary, I'll try to find some of those articles and send them to you.
Thank you.
So this is on the trail that goes to a lake called Ghost Lake. I have a picture in a minute, but this eruption happened in May. And because it was in May, you had basically the dead trees where it was outside the blast zone, but also trees didn't have to start from scratch. There were many trees that were under the snow cover, and therefore, and once the snow melted, kept growing. This is Ghost Lake, 10 miles from the crater. It's technically outside the eruption zone. It's sort of close to Norway Pass. And the volcano is literally 10 miles exactly the way the camera's pointed. And because that hill is between me and the volcano, basically it sheltered those trees somewhat from the blast. It still killed them, but they didn't drop down. Where I turned the camera around from exactly the same spot, and this is the hill behind me, where the blast really hit it and blew the trees down. And you can see piles of pumice. You can see the white rock. Now, most people don't know there was a second eruption. Second eruption was 2004 to 8. And again, you can see the red arrow, I believe in 1980, but the blue arrow is where eruptions started happening in 2004. They knew exactly where these earthquakes were. They could also plot them XY coordinates. It was right in the middle of the crater. They knew something was going to happen. And this is September 30th. I don't know the exact day. I think a day or two before that, I happened to be on the outside of the mountain with a friend of mine. We were hiking around, and we saw these helicopters going around. We could see climbers going up the ridgeline with binoculars. And we turned on the radio the next morning. They said they'd closed the trails. There was activity inside the crater. So the first thing that happened, it uplifted the glacier there, and the cracks appeared. And geologists have an interesting way to name things. They called it the loaf. They called the old lava dome the opus. And then it got more bigger cracks pushing up. And then eventually it burst through, and there were some eruptions. And the ash that came out of some of the bigger eruptions went all the way to the north. And this picture, I think, is looking west, and the ash is flowing from the winds from the south, and it's going to Mount Rainier. Now, on top of, besides the eruption that was going on, some rock, unlike the first lava dome, 1986, began pushing up through the glacier. So you can see in the middle of the steam, there's this rock coming up. And eventually became in the middle here, what's called, they call them whalebacks. And they really didn't, it came out, as far as I can tell, on the side of the plug, the old lava dome, and became very smooth on the top. And it kept pushing up. And there are cameras on the rim, I'll get to that in a minute. And every day I'd come to work in 2004 and 5 and wonder what's happening. What are the new pictures? What's being extruded? And everybody wondered openly what was going to happen when this whaleback hit the wall of the crater. And nobody had any idea. And it turned out it would hit the wall, it stopped moving, and it basically fell apart. And then another whaleback got extruded somewhere next to it. They're pretty big, to say the least, pretty spectacular. Very much like a whale breaching in many ways.
So can you, I'm not sure I followed that. You're saying this was being pushed up through, so there was a mound there in the middle. You're saying this was being pushed up, emerging from that mound?
No, the mound isn't moving. The old lava dome here is to the left of where the whaleback is.
Right.
And it's not moving. It's solid, and it's this huge, heavy plug. And it's sitting on top of, what extruded from 1980 to 86. And as far as I know, and this is a layman, is the magma and the pressure found a weak spot.
So this is to the north of that plug, between the plug and the big crater wall. It's a new spot that's coming up.
It's actually to the south, but it's right. It's between the old lava dome, the plug, and the crater wall. And it actually is splitting the crater. Right. Where the crater is a crater to the left and the right, east and west arm of this crater glacier.
Okay,
why is it so smooth?
I'm sorry?
Why is it so smooth?
I think it's smooth there because it was being pushed against the edge of the plug, but I don't know.
John,
So
what's the relationship between earthquakes and eruptions?
Well, the earthquakes, as far as I know, the earthquakes from here are basically, it's the magma moving in the chamber, hitting against the side. I don't know, it's various mechanisms as the magma is moving up. That's about as much.
Earthquakes precede eruptions?
Yes, in general, I think this eruption they do. I don't know whether you could say that for all volcanoes.
I suspect they're relatively small earthquakes per se, but it's as the magma is working its way to the surface, it's shifting things, and that's being picked up as vibrations in the rock.
Yeah, I don't know whether there's a scale on this. I don't know whether I can't see it. There is a scale on this, and I believe the size of these circles, and I believe we're talking on the order of the Richter scale of 1, 2, and 3. So yes,
it's pretty tiny.
Very tiny.
So earthquakes via tectonics are different than those via volcanoes.
Oh, sure. Volcano earthquakes are the magma moving, and most normal earthquakes are the shifting of plates.
Got it.
So this is a device, cameras, and instrumentation loaned from the Hawaii Observatory, which Kilauea, and has active volcanoes, and they were part of the monitoring system. They set up cameras around the rim. It's called Brutus, just the top of where that text is. That is pretty amazing. They were able to survive and get many pictures. And as I said, they posted on the web. Another picture of the whaleback is a USGS picture. It was their arrow there. And again, it shows the whaleback going up and some rock fall to the right of the whaleback, the original dome, and the initial spine that came up in the beginning, I think is in the lower right. It's pretty hot. They posted some pictures where you had the infrared picture and the rock itself going up to 200 degrees centigrade here on this one, which I think is about 400 Fahrenheit. I believe I've seen other pictures where it goes up to 300 degrees centigrade. It looks solid. It's pretty hot, to say the least. They posted some pictures where you could see literally from the same camera in the space of an hour. This is the whaleback beginning, bits and pieces. It's unstable and it collapses. There is one picture where you can see a movie on the website of multiple whalebacks being extruded and falling apart one after the other for about I think it's a 2-year movie. Obviously, they want to study it. They made these things called spiders, which are a box with instrumentation and 3 legs on it that hoist it up on a helicopter, go over the whaleback, and literally just drop it in position on the whaleback. Some of them got destroyed with explosions within literally 2 days. Some lasted longer. This is the East Crater Glacier, and cracks in it. And basically, you'll see in a minute, it lifted the original glacier up and basically it began flowing down out of the crater. There's another view of it, and then there'd be still eruptions. So there's the same almost picture with ash on it. This is from another place where actually this is not the East Crater. This is the West Crater Glacier. I should rename this, flowing out. And I think after about 1.5 years, the East and West Glacier met, flowing out to the north of both lava domes. They named this camera spot Guacamole. Regretfully, I could not find a better picture of this fact sheet that they put out. And there were a number of whalebacks, and as one would stop and fall apart, another one would be extruded. I think there were about 5 of them that busted through, and it was literally clockwise formation around to the west around the old lava dome. Here's another picture of what it looked like, the glacier that had been formed and where magma was being intruded and pushing up. And for a sense of scale, there's your sense of scale as to how big this the domes were. And you can see it got pretty high. It almost got to the rim, but not quite. This is the view from Johnson Observatory, looking down into the crater with, yes, clouds, but there's steam rising. They closed down Johnson Observatory. Eventually, after 1 year or 2, they opened it up while lava was still being extruded. It was relatively safe at that area. It's another view looking down different places. And in particular, this shows in the upper left is an arrow for the crater hike, which I'm going to get to now, where you get to go close to the crater. So again, this is what it looked like at the 96 when I was up there first. This is what it looked like. I think I was up there around 2010. And generally the same position. Now, the other force I mentioned earlier was lahars, muddy. There were these mud flows, a combination of landslides, melted ice and water, just everything just mushed together, and they can be quite fatal. And these lahars killed tens of thousands of people in a South American village when a volcano erupted. Here you can see that there's some growth in the middle of where this lahar came down. And that picture was taken where the red arrow was. It's the end of this road. You can drive there. And from there, I hiked up to Plains of Abraham, which is where the blue arrow is on the east side of the volcano. On the hike up, this is another picture of Muddy Creek Lahar. Yes?
John, could you go back to the trail map? I wanted to see, what scale is that? Like, how long is a mile generally?
I'll have to add that. I really don't know.
Yeah, okay.
I can put it this way. From the red arrow, you can hike to the blue arrow and back in 1 day. I can say that. It's a good hike.
Do you know how wide the crater is, which you can kind of see on there?
It's a good question. I don't want to guess.
All right, fair enough.
So you can see it's pretty barren, and now and then there are flash floods going down these lower lahars. Then you get up to the plains of Abraham. And this picture in particular, I know was taken around 2005 or 6 because the eruption is still going on. And there's some, plume, some steam coming up from the other side of the crater. And people had collected the pumice and made this trail marker there for a flat area with the volcano rising right out of it. And hiking around. Again, Mount Adams to the east is very clear and really beautiful. But there's also restricted areas. And if you're in the blast zone, what was yellow there, in particular, say camping is not allowed. Well, yours truly really want to camp and see what it's like on Plains of Abraham. Well, the yellow zone is where it's restricted. But below that blue arrow is still the eruption zone, but it's not restricted. And I checked with the rangers. They said, yes, you can camp there. The problem is where you're going to find water. So I decided to do a trip, have enough water to last a day, if necessary, go back the next day. So camped up the north end of Plains of Abraham, set up my tent, and hiked around. And sure enough, as you go down, there was no water. But going further down where there was a little bit of where there would have been a flash flood, I could hear wind, and later I realized it was a waterfall. Found water, pumped my water, I could stay there a few days. It drizzled that night, so I put up a tarp, got lazy, left some of the camping gear. There's just a trickle of water there. Took a pee in the middle of the night, a raging stream. I knew I was in trouble. And some of the camping gear went over this waterfall. And I searched around, and I basically was able to find almost all of it. You can see there, blown up on the right, my camping pots had come to rest on the top of this little drop off. And then it became absolutely beautiful. It's a great place to camp. I hiked around. This is Muddy Creek from the top, looking down. Did another hike. Shouldn't do this anymore. I was by myself up the side. And you can see it's another view of Plains of Abraham, a very flat plain. And I believe that little hill, this ridge to the far in the distance there, is much older rock, much older than the volcano. And my guess is, I haven't read this, the Plains of Abraham is just filled up by debris from previous eruptions. You can see from where I was pumping the water around there, you can see that the blast really just scoured. It did in many places. The blast just, this ridge line just got torn apart. Also, there'd be over the 40 years since the eruption, you get some significant rainfall and floods. And you can see on the left, taking out trees there. And on the right, that's a temporary bridge for Route 99, because the old bridge was just literally washed away. And that's one of the culverts down below, what's left of the culvert. They hope to divert it. In another place near June Lake, same thing happened. You could see how the ash and boulders had filled up the culvert on the uphill side. The water had then, the stream went over the top of the road and then just cut through it in the flood. And, there's an 8-foot straight drop straight down. So in one of my hikes there, Plains of Abraham, this is 2014, I was there. I go to this place called Windy Pass, which is close to that limited zone where you can't camp. And I heard these voices. There was nobody behind me. I got to the pass, looked down the other side. There was nobody there. I looked up the ridgeline, and there was this guy. I call him an old guy. He's probably the age I am now. And it turned out I caught up to him, the young woman. Turned out he was a professor of geology, doing samples. He'd had a heart attack, and therefore they wouldn't let him carry any gear, but they let him go do hikes and collect samples as long as he had a graduate student who was carrying all the equipment. And you can see in the lower right there where I hiked around some more and looked down there collecting samples. So, we talk. He apparently is an author of one of these books and articles about the volcano. So he said, "So have you been in the crater?" I said, "Are you crazy? You got boulders the size of cars coming down. You can't go in the crater." And he said, no, you go close to it. You don't really go in. You should call up Mount St. Helens Institute, the same people who give the permits to go to the summit. And sure enough, I called them up. I said, I'd like to go into one of these crater hikes. And they said, why do you ask? I said, I think I can fill up a trip. Their answer was, well, when do you want to go? Which I did, and we did a trip. So the hike basically goes across the blast zone here, left to right. That waterfall is Lowit Falls, and we cross Lowit Creek, and we should cross it. And then there's a thing called Step Creek. Those are two main creeks coming out of the crater. Except when we were there, there was a torrential, there's also the sea, I should move the slide earlier, where the two parts of the glacier were advancing out of the volcano to the north. So this is idealized where you're supposed to go. You go off the trail, you're not allowed to in the blast zone, but Mount St. Helens Institute allows you to do it. You follow those blue arrows off trail, up into the crater, into the breach, not really into the crater, where there are no landslides. You're really in the middle there, the first blue arrow at the bottom that's pointing up that go over the H of Helens. You're really in between Lowit Creek and Step Creek. So basically any landslides coming down the side, rocks coming down, to go into those canyons, those valleys, and you're really pretty well protected. But we couldn't do it. We couldn't do it because there'd been a torrential rainstorm and wind, tremendous storm the night before, 2 nights before, tore apart the tents that we were camped at in Mount St. Helens Monument. And so the day before the hike, we packed up and went to a hotel. So the hotel is over an hour drive in Randall. So it really put a real crimp in whether we were going to be able to do the whole hike, get everybody together, go in. And when they got up there, the guys took a look at the water that was coming out and said it was totally unsafe to cross that creek, so we couldn't do it. We either could try to go lower down, but we probably wouldn't get up to see the glacier, or we could go another direction, what's called Crater View, a different kind of hike, which is what we opted to do. And it's just, as you can see, to the east of where the crater is, that's the blue arrow, that's where we went in. So there's a picture close to where we limited where we hiked in, the west crater wall, the fog lifted for a little bit. And when we got to the top, that's Lowit Creek before the waterfall coming out of the crater. The actual glaciers underneath where I wrote Crater Glacier, a lot of rock and debris and some ice. And then you could see the lava dome, the original lava dome, 8086. I don't think we could see the newer lava dome. Hiking out, the fog lifted, saw a herd of mountain goats, Spirit Lake again, and I believe that's called Truman Ridge, that was just blasted again by the landslide and the pyroclastic flow. So I had to go back, of course. So I had another trip, didn't quite fill the next trip up, but still got a bunch of people to come. And it was foggy day, we're hoping the fog lifts. To the right, you can see the herd of elk that's on the side of a ridge line. And the elk really played a very amazing role in breaking through the original crust of the explosion in 1980, 81, 82. And basically the water get trapped there, seeds would get trapped there. Lupine were the plants that began growing there and revegetation. It was, I believe, the end of July, beautiful flowers. The one on the right, really can't see it, beautiful purple lupine flowers, and that's Step Canyon. So you hike up where the landslide came down, you get to an inflection point where you're now going into the breach. You're going into where the mountain was. And luckily the clouds parted, and this is the crew of us hiking down in. To the left is Step Creek. To the right is the west wall of the crater. And you can see, I think the dark right on the left-hand picture is the original lava dome. And the lighter gray rock you see on the right is the lava dome that was extruded from 2004 to 2008. As we're hiking up, there's this reddish cinder cone that we passed by Step Creek as we hike down and go out to that middle part I mentioned. And this is fascinating. This cinder cone is basically something that got extruded hundreds, thousands of years ago in that area. but then later rock was extruded around it, above it. We're well into where the landslide and the eruption happened. And it was only because of the eruption and Step Creek eroding the side of it that the cinder cone became visible again.
At this point on your hike, or at any point on this hike, do you begin to feel heat from the rock, or are you still too far away for that?
This rock isn't hot. The water, however, can get warm, and we'll show that in a minute. They actually mapped the advances of the glacier. I think under COVID, they had a breakdown. I'm not sure exactly where it is now, but every year it advances, and you can see sort of like the dark areas on the left and right of where the glacier is. It's falling, beginning to go into the top of Step Canyon and Lowit Canyon, where the creeks come out of. And then they make us.
Is that a fairly fast glacier movement?
It's fairly. It's the only glacier that's advancing in I believe, the lower 48. All the other ones, because of climate change, are retreating. But because it's in shadow, it hasn't really gotten through the breach. It's still in shade a lot of the times, so it's still advancing. And of course, there's still rockfall and snowfall that is feeding it inside the crater. So exactly how it's working, I don't know. And you can see this is a matter of meters. So each year, in some places, the lines overlap. It doesn't really advance. I would say this is a matter of maybe 30 feet a year or something like that, 50 feet, depending upon where you are. As we hiked up out of that picture with the cinder cone, we got to a point where we're going to be at the top here, close to the glacier. And they made us walk across one at a time, because this glacier is advancing. There's, as I said, 30% rock and debris. And every 5 minutes, there'd be a rock that'd be falling out of the end of this glacier, falling down the front of it. And this looks like we're having a lunch break close to the glacier, actually pretty far away. And they made us go single file, so if something happened, only one person would be in danger. In terms of your question earlier about temperature, there's a degree centigrade of the water, the hot springs that will happen. And so one by one, they get covered. Some of them you can see are below where the glacier have advanced and covered them over, but there's still water being heated below. And you can see in the upper left, you can see the position of the guacamole camera. That is a picture going back to the Muddy Creek, the east side of the volcano, where I found out from looking at the map, and I didn't mention it, but if you look at the map, there was a trail, short trail, and on one of the old maps I looked at, it showed a lean-to. And sure enough, I hiked up, there's my two stepkids, and they had two shelves where you could sleep, and we hiked there and stayed there for, I think, 2 days. We were in preparation then to climb the summit. The last time I tried to climb the summit, we got to a place up the side of the volcano, not the usual place, to get a jump up on hiking up to the volcano, the summit the next day. We saw these orange cones. We didn't know what was going on until somebody came by. They were putting up the cones for the people who do once a year around the mountain hike, which I don't know the distance. I could Google it. I should Google it, but they literally run the volcano in 1 day. We decided to get up early enough to hike around the path that they would take and we would take to get to the spur trail going up the volcano. And we got to it just before the first runners went by below us. And it was one of these days, it was cloudy and patchy clouds and sun here and there in sky. You're hoping that it'll clear. Perspective view under the blue arrow, there's some hikers coming up that's looking down the volcano. And in terms of how you know where to hike, underneath those 3 blue arrows are these huge poles that they have. Were very helpful for my first hike of knowing, are you on the trail or not? But when you get to the top that day, it was completely socked in. You couldn't even see the people on the left, barely see them. On the right, those 6 people are at the summit. And that's me with my stepdaughter, stepson, and Bill Menrath, instructor at the University of Cincinnati in health and safety. But we made it to the top, no view. This is what it looks like. This picture was taken, I believe, 2007, 6 or 7, and it shows where the different parts of it are, but it was still, different spines were still coming up. Going down is another story. Had to read the riot act to the kids, because if you don't follow the trail, and they were getting ahead of me, I don't know if they were following the trail, you go down the mountain, you can go any number of different ways. Going up is easy. It's only, you know, you're going to get to the top one way or the other. Going down is a little trickier, but we all hooked up, it lifted, and we safely got back. So just the last to the sort of conclusion, this is what it looks like on the south side. Not a beautiful place, June Lake, with a waterfall. This is a nighttime picture, 10-minute photograph of Mount St. Helens with the cloud over it, with the Big Dipper on the left. I climbed Mount Adams once, and this is a picture of Mount St. Helens, 30 miles away from Mount Adams, with the moon setting. And in terms of what's going to happen, we don't know exactly what will happen, but it will erupt again. My personal view is I think we're going to have an extrusion in the next 10 years, given the past activity, but who knows? What could happen is what we've seen from a Russian volcano. It looks very similar to Mount St. Helens. It erupted in 1956, and it's much more active. It extrudes lava, I believe, almost every year. And it has built up a dome in the middle that is higher than the crater wall. And eventually we'll fill it up. Then it'll be quiet for a while. Then it'll blow up again. If you really want to know more, and if you're in Cincinnati, you can borrow these books. One is about the 1980 eruption. One is about the 2004 to 8 eruption, 2004 to 6 rather. And one is about the ecological changes that have happened in both the flora and fauna. So that's the presentation. All I advise you is go see it, whether you hike the crater or not. It's an amazing place. So that's the presentation.
Thank
There
you for
was an
that. Those are pretty
article.
awesome.
There was an
sorry?
article in the Times recently about volcanoes, and it said the United States had some very large percentage of volcanoes in the world. I forget how many, at least a tenth or more. And you don't think, no, I don't think of United States is particularly volcanic. But there are a lot. There's the Cascades, and then Alaska, I guess.
Yeah, I think exactly. And since you mentioned Alaska, the Alaska and the Aleutian Islands, all those volcanoes, they're basically there because the Pacific plate is moving north and going under whatever plate it's called that Alaska's on. And that is causing those volcanoes.
It's weird driving through Oregon. If you come from California or the Rocky Mountains, you know what mountains look like. But then you get to Oregon, and it's all these cones.
Well, you know, they're also, it's not active, but there are a number of cinder cones that are south of the Grand Canyon. And what people don't know is there's not a volcano, but I got to say it. There's geological time, about 10 different times, lava was extruded down the side of the Grand Canyon, into the Colorado River. There's some where it was extruded out from the bottom through the Colorado River, caused dams, blocked up the Colorado River, backed it up, made a big lake a number of times, most inside the inner canyon, and then the water topped it and eroded it away.
So John, any safety concerns about hiking around up there?
Don't do it when it's active. You know, volcanologist is a very hazardous job. Dave Johnson took the position for somebody else, forget the guy's name, who was going on a break. That volcanologist later was part of, I think, about 20 or 30 volcanologists who went to Japan, were on a ridge line of a volcano that I believe was active. They thought they were high enough and far enough away that survived. And it was one of these pyroclastic flows, which is superheated gas, and they all got killed.
I was rather amused on one of the slides you had the rules of camping and the irony of no fires. You're not allowed to make fires in the yellow zone.
But for
Yeah,
you hiking around, I mean, you always know far enough in advance whether there's going to be any activity or not?
In general, yes. I mean, in general, I mean, like, first of all, let's take the 1980 eruption. This is the only volcano I'm not familiar with. In 1980, 3 months before, there were tremors and there was a crater. It was a snow-capped peak, and there began being a crater. There's a famous picture of a hiker at the rim of that snow-filled crater when the volcano was closed, totally illegal, climbed up it, and there it was on the top. That was pretty crazy, to say the least. So they knew months in advance. There was the bulge. I mean, but they didn't know exactly what would happen. They didn't know it would be a horizontal blast. That's pretty rare, I think.
So did they close the area for several months, or how did that work?
In 1980, it was closed. And in 1980, as I said, it was closed all the way down the Toutle River, the river that comes out from the blast zone. And people were, as I said earlier, they're at the gate about to go in. And it was sheer luck, really random luck, that it was Sunday morning, 8:32 a.m. that had happened. If it had been Monday at 9:30 or 10:30, there were lumberjacks who would have been active, and there would have been people probably going in to retrieve materials. Turned out at the time, I forget the woman's name, who was the governor of Washington, was a geologist. I forget her name. And so she took the warnings pretty seriously. The eruption in 2004, as I said, I was on the outside, and the eruptive gases that you saw were days, if not weeks after that. It was illegal to be inside the crater to begin with. I don't know whether it ever threw rocks outside the crater. And when there was that activity, they closed down the trails. They opened up some of them. I wasn't illegally there when there was that wisp of smoke above the crater rim. That was legal. And I don't know, I don't think the rim was open there. It was only the trails around the mountain. And they may have also closed, I'm not sure, the very front of the volcano. Low it falls, the trails that are there in the blast zone. In terms of fires, I got to say, there are no fires in the Grand Canyon and in the blast zone, Mount St. Helens. It ain't a matter of the danger. It's because it's an ecological zone where there's very little wood, and they basically want the wood to be there to deteriorate, to help grow whatever's going to grow there.
Yeah, I understand. I just thought it was funny.
It is ironic.
I do remember that before the eruption in 1980, they were quite aware about the dangers, and there was this whole storyline about some old guy who lived up on Spirit Lake and refused to evacuate. And of course, he was never seen again after the explosion, or his house.
Harry Truman and his 30 cats. Yeah. His body was never found either.
Yeah.
Didn't whoever find 15 of the cats?
So is there a whole history of eruptions before 1980?
Oh, yes, there's all history. Most of it is in the last 3,000 years, but geologically, I think the history goes back 30,000 years, and they have different periods when they call it. There was active here, active then. And there actually is a famous painting from the 1850s. Somebody did a stylized painting with Native Americans in a canoe on the lake with this red fire on the side of the mountain. And they believe that was one of the minor eruptions that happened there.
What's the story about Mount Hood? I mean, I always thought Mount Hood potentially could be dangerous to Portland. Is there any risk of that? It's about 15 miles away, I think, if I remember correctly.
Yeah. A few things. One, Mount Rainier. Let me talk about Rainier first. Rainier is a very different mountain with a really serious danger, which is the volcanoes are different. It's many different layers, and these layers are separated by other very weak layers. And the history, and you can see on the east side of Mount Rainier, there's the remnants of where the mountain used to be. You can do a trajectory and you can see where it used to go up. And basically what happens is a whole chunk of the mountain would make the landslide at Mount St. Helens look like nothing. They've dated them that debris flow will come down Rainier, and within 10 minutes or something like that, it'll get to Puget Sound. I want to bet with a guy. I got a beer bet because he said, no, I wouldn't get to Puget Sound. But if you go on I-5 near Olympia, between Olympia and Seattle, you'll see there's a warning sign. And I think it's tsunami area or landslide area. I forget what the sign says, but it basically says if these sirens go off, they will shut that highway down and, you know, get the hell out of there. Now, Hood, I don't know Hood geologically. I don't think it's active geologically. However, Hood has tremendous problems about ice falls, and people regularly die. Well, they die in all the mountains, but they die because they climb Hood and it is an ice fall and it kills people. Rainier is very high, over 14,000 feet, rises basically from sea level, should be the highest mountain in the US, but it's not. And people die on Rainier. I'm not sure exactly what happens there, but yeah, it's a 2-day, at least a minimum 2-day hike. Go out to a place called Muir Cabin. It's the main place I know people do it. And you stay there overnight. It's a real crowd scene apparently. And then you get up at 2 in the morning when the ice and snow is pretty solid and less chance of falling through crevasses, and you summit. So as I say, I'm addicted to Mount St. Helens and Grand Canyon. And as I often say, I sleep on my addictions. And so I embrace my addictions. I'm proud of my addictions, and hopefully I haven't lost a wife or a job because of them.
So about Canada, has it got more volcanoes than the US?
I don't know.
No, no.
It was an interesting comment, 10% of the volcanoes, and I found that surprising statistics until whoever said it said Alaska and the Aleutian Islands. And that makes a lot of sense. But, you know, it's a ring of fire. It's basically where the continents, you know, is subducted under another continent, and we have earthquakes somewhere inland from there.
Yeah, that was my question. How far south does the ring of fire go? Down to
In the U.S., the Cascades, I think it goes to Mount Lassen, Northern California. I don't think, then the Andes are volcanic and they erupt regularly. So it goes much further. It goes Tierra del Fuego, goes all the way to the south. I'm not sure. They could be volcanic in origin. I was in Chile once and I stayed at a B&B on the side of a volcano. I didn't realize till I got there that volcano had erupted a year before. And when I did a hike around a volcano near it, that was gorgeous. You could take the chairlift up and hike around. You could see, I have a picture where the ash is sort of, the snow is a little bit gray from the eruption that happened like 8 months earlier.
Any more comments or questions?
Well, thank you for your time and your questions. It was good.
Yeah, there was only one comment in the chat. It was Cynthia saying that the picture of Ghost Lake was very beautiful.
Yeah.
John,
It doesn't-
John,
It doesn't quite look the same anymore. That picture was taken, I think, 15 years ago. So the other trees grow up, and we camped there and it was wonderful camping there until I realized the next morning it's not that far in, 2 miles or something. So fishermen come in and out during the day.
I had one question. Just one thing that occurred to me I forgot to ask was you talked about how your campground had gotten washed away. You walked away from it and got washed away. Were you actually near a stream, or just was it just wherever you were that the waters decided to come down right there? Or
It was the bottom of the Plains of Abraham, fairly flat, and it was a little bit of a depression, but it wasn't clear there really was a stream there. It didn't look like a stream or anything. And I put the gear sort of up on the right, whatever, maybe 3 feet away, 2 feet away from the bottom where the little trickle of water coming through.
Okay.
Learned a lesson I should have learned, I learned as soon as I saw it, I was like, oh, how could I have done such a stupid elementary mistake?
John, I'm curious in terms of your addiction. What fraction of your time that you spend outdoors relates to Mount St. Helens?
I'm sorry, what about the time?
I was saying, what portion of the time that you are spending outdoors relates to this area?
Good question. I don't know. Yeah, you know, it's probably going to be much less now, quite frankly, a lot of the trips got combined with work that would pay for me to fly to Hanford, Washington, hop, skip, and a jump, or a meeting in Portland or a meeting in Seattle. I don't know. I mean, the Grand Canyon is the other big pull. And the third place I should tell everybody is something called the Scablands, where the glacial floods that are in central Washington, which is all basalt lava. And there are very wild geological formations that are a result of a glacial flood, because the glaciers 10,000 years ago blocked the Clark Fork River near Coeur d'Alene, Idaho, formed Glacial Lake Missoula, and eventually and repeatedly that would break through and just wash across central Washington.
John, was the Scabland where NASA trained astronauts?
I don't think so.
There's
I think
some
it was-
film where-
I thought
Yeah.
there was the White Sands was in the south. I'm not sure. It could have been.
I'm not even.
I should say with the Scablands, it's an interesting story given this group often does scientific presentations. The guy who basically, people should mute if you're not talking. The people, there's a guy, J. Harlan Bretz, J didn't stand for anything, who was a geologist in 1922. And he proposed that there was a big flood that went across central Washington that caused this, but he didn't know where it came from. And timing was awful. It was just after sort of geologists were in ascension for a couple of decades of beating back the theory of it wasn't a flood and the biblical story of how geology happened. It was also the triumph of uniform, of basically layers being laid down over time, one after the other. And thirdly, geologists at the time didn't really publish and investigate articles on new evidence. They taught basic principles. And so they didn't go, they just discounted them and said it's not true. And 40, 50 years later, he got the Peabody Award for geology from the USGS. And when he got the award at the meeting, he said, "What's the use? All my opponents are dead by now."
John, do you have a talk on the Grand Canyon? There's really weird things about it. Didn't it used to flow the other way? And so forth?
I should do that. And after doing this presentation, the original one for the Sierra Club a decade ago, and then beefing it up for this one, I've thought about I should do that. I should do Scablands and the Grand Canyon, especially because I flew once over the Grand Canyon, and I was, as I always pick back when I flew, a window seat, not over the wing on the shady side. So there I was heading west, and I was on the north side of the plane looking down, and the person sitting next to me said, "Do you know where you are?" And I said, "Not only do I know where I am, I could see each of the valleys that where the trails were that I hiked down and camped in the Grand Canyon." No, I should do the Grand Canyon. It's a spectacular place. And the Little Colorado, the growing theory is that there's stream capture. That was formed from Las Vegas. There was one of the ancestral rivers coming out, was eating away going east. And the Colorado River came down, but flowed south down the Little Colorado, which now flows north to the Colorado River. And at some point that flood, that lake, there was a lake there and the stream, they captured each other. But it's very strange because the Colorado River at the Grand Canyon goes right through Colorado Plateau, which is a really high geological formation. And if you go to one part on the north side, you can, it's amazing. You look out and you can see how far lower down everything is. And the river was not there in the beginning, geologically speaking, they know from dating it. And it wasn't a question of the river going through it and the rock rising and the river cutting through. It's pretty clear it was there. And the question is, why did this river go right through the middle of it? How did that happen?
Well, I think we're gonna say goodbye, John. We enjoyed your, yep.
Take care. Yeah, I think I'm
Bye.
over my
Nice to
time.
meet everyone. Yeah.
Yeah.